Yeah, thank you for having me here. This is actually something where I want to sell you basically the project we have been working on internally. So this time not selling you shoes or something in fashion, but I hope I can somehow convince you to look into the project that we have open sourced some time ago, and we are serving us very well in our setup with a huge number of teams and different heterogeneous infrastructures, different databases and services running. So I hope you take a look later. Yeah, I'm Jan from Berlin here, so ask me any questions later if you want to. I hope everyone knows Zalando here. That's getting better and better when you go to conferences. People know that we are doing engineering work, that we are developing software. On the initial kind of advertising tours we did, we still had to explain that I'm not selling shoes to people directly. We now call us Europe's leading fashion platform. We deliver to 15 countries across Europe. We have 3 huge fulfillment centers. We serve something like 18 million active customers. Last year revenue is 3 billion euros, so it's growing and growing. We serve 135 million visits each month. And probably most surprising to many people today is that we have more than 1,000 people in technology. More than half than this is really engineers, so developing software for logistics, for the front end, for all the infrastructure that we are running on. If you're more curious, look into our tech page. It includes a blog where most engineers have started writing about the stuff we are developing, so feel free to take a look there. The history here, some years ago we were still very tiny, and then it grew and grew, and we came from this PHP MySQL shop, then we switched to Java, Apache Solr, and Postgres, deployed almost everything using Tomcat in our one data center, then we got the second data center built up, number of employees and projects grew and grew. Then there came this language diversity, Docker arrived, deploying to AWS arrived, so today there is not only Java, there is Node.js, there is Scala, there is Clojure, there is Python, basically everything you can imagine, and this makes monitoring, keeping track of stuff that is running way more complicated than before. Yes, so last year in March, our VP of engineering introduced something to us called radical agility, and this was basically the starting point where engineer got much more power, and with more power there comes more responsibility and also autonomy for everyone. So this meant basically our move to AWS was announced, and everyone thought, oh cool, we can go into the cloud. Every team got its own account, everyone can pick technologies they want because people were initially starting to get fed up with deploying to Java containers. Everyone wanted to have the fancy, shiny new stuff. So we built something called Stups, and this has been open source, and maybe some of you have heard about it. This is a very slim layer on top of AWS. It's not removing any privileges from our engineers, so they can still log into AWS accounts, they can deploy whatever they want, they can use the AWS services if they are interested. But what's crucial here is really there is one AWS account for every team, so we have isolation on team level. We deploy using Docker, so one EC2 instance running one Docker container. We have managed SSH access, so you still get root to the machines. The only thing is you have to provide a reason on the console and then you get immediate access. There's no limits or constraints here. We agreed on that communication between services and teams is basically constrained to REST, secured using HTTPS and OAuth 2. And another important stuff from compliance is this traceability point. So this is why basically we run our own Docker registry called Peer1, where everything stays the same. You can't override stuff, so everyone can later figure out what you actually deployed and did in this platform. But important, a lot of power to engineers to pick technologies, to decide what they want to use and to solve their problem in an efficient manner. If we go one step further here in Stups, how do they deploy? The most common deployment tool is the sensor tool. It's a very slim wrapper around CloudFormation. So most of the stuff we deploy is used using CloudFormation, basically EC2 instances in an auto-scaling group with an elastic load balancer from Amazon in front of it. Yeah, so you build, develop, you push to Peer1, our Docker registry, and then you start some instances, and then common to all these instances, you will also see later, is this Topage AMI. This is a Ubuntu image with a few agents for logging, for metrics from Prometheus, and this basically spins up, runs your Docker image, and you're good to go. So far to this basic infrastructure here in all the accounts, so this is common. I already mentioned this, there is one account per team, HTTPS JSON, REST in between. We are not sharing any databases. You can't connect natively to the Cassandra clusters or anything. It's heavily driven by this thought of APIs first. And this, obviously, for monitoring makes it slightly more complicated because suddenly you come from 2 data centers where you can reach everything. Every team suddenly has its own VPC. You can't connect to the machines anymore. There's only ELBs visible. So this had to be solved also. So let's look at that one. That is basically, we came from this Isinga world 2.5 years ago, didn't work out anymore. People wanted to monitor way more services. They had to create tickets for the system engineering team to change the configuration. And this obviously doesn't work when you grow in projects. If you grow in languages, databases, and stuff you want to keep track of. So there was a hack week, and a few people decided, let's build something cooler, make it basically possible for teams to configure all this stuff on their own, don't interfere with the others, but still have one central monitoring for everyone. So now comes a little bit of sales pitch here. So the highlights, in our opinion, are basically it's very flexible and extendable. So we rely heavily on Python for checks and alerts. Checks is basically our data acquisition. So it pulls data in from some service, from a database, from business logs, from whatever you can think of. And then there is, again, a second part in Python that takes care of the alerting and sending notifications and so on. We kind of think it's easy to integrate, so we have REST APIs for almost all the functions. We use OAuth 2 for login and for securing communication. We built something for auto-discovery in AWS, so if you deploy this into your AWS account, it automatically figures out what is running in your account, and you can basically start monitoring from there. Finds EC2 instances, load balancers, auto-scaling groups, Route 53 entries, Elastic caches you have deployed, so this is pretty easy to work with. I will show you later. We are fully configurable via the user interface, so no restarts after changing config files and so on anymore. It's good for teams. So like I said earlier, we have 1 account per team. We have, I don't know, 90 to 100 AWS accounts right now. So this is a lot of stuff to take care of. But still, you build all these dashboards for your teams. You build dashboards in Grafana with data-driven stuff. I will also show this. So this is basically built in. And at Zalando, we have something called the incident team. So this is a great thing to have, actually. So while your team keeps care of most of your stuff, when you think something is important, you give one alert to the incident team, and once this pops up, so maybe they can solve it themselves with the privileges they have, or they basically call someone who can fix it. So we needed there also some infrastructure to delegate alerts to other teams to take care of them. Yeah, fast and scaling metrics, so UI and stuff is powered by Redis, which works really nice. And the other backend stuff for Grafana is KairosDB, which is a great open source product for time series. It stores everything. It's based on Cassandra, so really we don't need rollups and everything. We keep the data as we gather it. And something that was added last but not least, end of last year, was actually we have tiny iOS and Android app in the works, so you can basically from your phone access the dashboards. We have also push notifications to both systems, and all of this is open source. So I'm not going to promise you iOS app to work flawlessly. It's still in works, but basically you see people start contributing on whatever they need, and it's all on GitHub. So let's take a look at how does it look like. This is a screenshot taken from the demo that is running publicly in the open. So if you go to demo.zedmon.io, you can log in with your GitHub account and see what's going on. And this is how the UI look like. So we have some widgets everyone needs, so charts and so on in the top. And then we have all the different alerts in the bottom right. So the red ones are the more important ones. The orange ones are maybe less important. And then you have the yellow ones you probably don't care about. It's pretty hard to get the dashboard green, but some teams actually do this. We have immediately some charts here on the dashboard because we saw in the past it's important to figure out if this basically came up quickly, this alert, in the last 5 minutes, or basically has it been growing for the last 30 minutes or days and just slightly reaches this threshold where the alert pops up. Yeah, we'll go into more detail later. If we take now, this is too small, but basically what's important to take away here is that we have something that is called entities, and entities is what we basically observe. So alerts change always their state for certain entities. In most cases, an entity is an EC2 instance or a JVM running and so on. And you have here in the bottom some green lines, some red lines. Seems the resolution is really bad. It looks better on my screen. So basically there are 5 green instances and 1 red instance. So basically this is where the threshold was violated. or in this case, the connection was refused, and you see, okay, that one is wrong, I want to investigate why it's happening. If you could read it, here's also some Python code. You will sadly have to look at it later, but basically we have some Python wrappers around HTTP requests, around SQL queries, and so on, and it makes it really easy for people to establish HTTP connections, pull in some JSON data, or communicate to Postgres clusters, MySQL, MS SQL, whatever you can imagine. It's all there. There's stuff for Elasticsearch and some cloud logging providers we are using. So, and if whatever you use is not there, basically you write a few lines of Python, because Python is great and it has basically libraries for everything you can come up with. So, since we are in the cloud, we also started building some more UIs that automatically populate. So you just log into the web later and take a look at it. But basically, we have here 4 applications deployed. Then we show you how many instances we are tracking, how many requests per minute are served, and then you get more data regarding the error rates, so 400s, 500s, and so on, to get a quick impression how your microservices in the cloud are running and performing. And hopefully, most of this stuff is black and not red. If we go into more detail here, you can pick the different applications deployed, and we track data for you if you configure it properly on the different API endpoints. Because let's face it, when you look at, for example, Elastic Load Balancer, CloudWatch metrics, they are pretty imprecise because they basically give you an aggregated latency, and this is often hiding that a certain normally very fast endpoint is suddenly getting slower. So what you see here is basically, would see is a UI over the different API endpoints you have, where we track also the different status codes, the average latency, and so on, the 99th percentile, so everything you basically need. Yeah, coming to Grafana, everything we gather, we store actually, so there is nothing hidden from any user. And this opens it up to Grafana 2, which is another great open source project, which we just basically stripped all the JavaScript, put it into our project, and run it on the same machine. So it's basically the same protection, requires full authentication and everything. And this makes it very easy to deploy in front of the Kairos DB and the other stuff you have. We are also working on Elasticsearch proxying, because we have in the future our logging in Elasticsearch, and you still want to have all the Elasticsearch features in our Grafana 2. You don't want to have a second tool. And then you define a Python expression. This one is basically the neat thing in Python. You have this powerful eval. We locked it down as good as possible and opened only, for example, HTTP GET to avoid people doing post requests across APIs. So what we have built in, and this is only mentioning a few, so HTTP is clear, Postgres, MySQL, CloudWatch, Redis. We still do SNMP, NRPE on the legacy infrastructure, so this is still important. SOAP requests and some of the cloud providers for logging are also in there. And in the end, it always returns a Python object. So between the check and alert, there is a Python object that can be serialized, and this is passed to the alerting. And then later on, you can figure out what you want to do with this data. So in one example here, and here I think people can read it, there is the SQL wrapper in the beginning here, and this is basically auto-injected with the entity from before. So then it already knows the connection string, it knows where to connect to, and then you just define what you want to select actually. And then that one takes care of querying all the entities that match the type PostgreSQL, and in this case you get a very stupid availability check against all your Postgres instances. Yeah, so far with this. One more example here, I think maybe people can read this here, doing an HTTP request, converting it to JSON, iterating over the keys, doing some filtering, and then again, that's it. Since not everyone in our company is as familiar with Python as we sometimes would like them to be, there's something called the trial run, and this is where you basically can start developing your stuff. There is basically a button, you press enter and run it, and then it runs basically across all the instances and deployments we have. It executes this, and if you're happy with it, there is a button to save it, and then it's basically done. This made actually, we didn't have this in the beginning, and then it was very cumbersome to work with stuff, but basically since we have this trial run button and users get immediate feedback, that is very useful to have. If we look at the alert side now, assuming that we got this JSON data or so from the check, the alert basically takes a look at it. So you can think of basically you have one alert for the write latency, you have one alert for read latency, but they both basically rely on the same data pull in from the Cassandra cluster, and this is how it's basically split. The nice thing is basically you can have multiple alerts on the same check. The check also only gets executed once, so if you consider running a bigger SQL expression, for example, and you have different stuff to look at, it's not really a problem because the query only runs once. The alerts are all team-based, so basically as a team you own this alert, but you can force other people to kind of inherit from this. So inheritance is like in any other language, they can override properties and thresholds and so on. This is pretty useful if you, let's say, have this incident management team, you basically hand it over to them, give them a new threshold, and they can take care of the rest. We stripped warning and unknown from Isinga back then, so there is only now you define your custom color and decide how you want to handle this. We also have no unknown anymore, never worked. Yeah, so there's only colors, and you pick this by agreeing on them while defining alerts. We are actually, well, let's say red has to be handled immediately, but this is up to teams. So we had this earlier, now it's slightly bigger, I hope. So I earlier showed here, we have 3 Cassandra nodes running here. You can see we are pulling in the load. Basically, we access the value dictionary, looking at the 5-minute average and say if it's exceeding the value of 13, let's make this alert pop up. That is basically what is shown here, and you have 3 Cassandra nodes at the bottom. I think this is understandable. Yeah. Again, let's skip this. I think there's enough time. What do you need else when you are running, let's say, deployment infrastructure? If you're deploying new stacks, new software versions all the time, you need some capability to actually say, I am deploying this. It's fine that it's unavailable. It's fine it's slower or whatever. So we built in this deployment API for downtime. So you can basically schedule downtimes ahead of time or while the deployment is ongoing, and then you remove it. This is pretty nice to have. Yeah, so downtime is there. Sharing and reusing of checks. Yeah, we are not hiding any data. So all this data in Zmon for the Zalando technology department is readily available and open for everyone. So you can, for example, start monitoring your client-side applications, your dependencies, so that you maybe think you can do a better job at monitoring your downstream dependencies. Yeah, and this is actually pretty nice to have. And you can look at other services, how they are performing if you are curious. And using this inheritance, for example, it's really easy to say, okay, this service from team B, I want to have this on my dashboard. You click one button, you get it onto your dashboard, and then you're done there. The deployment, and this is maybe a slightly bit more complicated. Don't be immediately scared by this. There's obviously a lot of services involved here. There is a CLI you run on your local machine. There's the front end, so far so good. And this is the API and the UI stuff, Grafana and so on is basically running in this controller application. It's a default Spring Boot application. Then we have something like the scheduler. This is obviously taking care of executing, or at least telling the worker to execute checks. So this one is aware of all the stuff running in your platform, all the alerts and checks you have defined. And then you have on the right-hand side the worker, and he is actually receiving the tasks from the scheduler to gather your data. And once he has acquired the data, he will write it back to Redis for the UI and to Kairos DB for the time series. So this is basically the kind of the minimal setup you want to run. The metric cache is only for this cloud UI part, but the nice thing is that for the demo I mentioned earlier is there is a GitHub repository with a script, and this is basically all Dockerized, and this script perfectly reflects all the parameters you need to set and configure if you want to run this on a single machine. So this is all in Docker. We are using the open source Docker images as well internally, so there's no difference between the stuff that is openly accessible and what we are running. And then you have to set a few connection strings to Postgres, to Cassandra, and so on, and you are good to go. So don't be scared by this picture immediately. And if we now think about this federation, you have all the different accounts. There is this kind of people would sell it as an enterprise feature, but we decided, okay, let's also put it out there. And this is the stuff we have in this data service. So this is our remote endpoint. It's running in one of our data centers, and all the AWS accounts are streaming the data in. So basically, this is how we bridge this gap from the different VPCs. All the team accounts are running a tiny subset of the Z1 services, one scheduler, one worker, and the Redis instance. They execute the stuff that is within this domain, and then they use HTTP to send it back to our infrastructure, and then we store it in this one big Redis for everyone and into this big one Kairos DB cluster. And this is basically how we can receive data from, I think, now 65 different AWS accounts, and still display all these metrics alongside the legacy infrastructure. If you are in the situation that we were in, we have 2 data centers, you have firewall rules, you have certain parts of your infrastructure. Basically, we also started building in this support for split workers. So the scheduler can send tasks to data center 1, it can send tasks to data center 2. So all this is in there, what you might need if you have such a big deployment. I think probably most people don't, but it's there. The worker can also report using HTTPS. This is what I showed you before on this slide. So it's all there. Because I promised something, what is this? Is it me? We have seen a lot of Jenkins slides today, so this is why I just want to mention this slide. There is GoCD that we are using that is actually pretty a nice tool if you have pipelines and so on. It's very easy to build the Docker images. So what we are basically doing, we are building lots of Docker images, first the open source one, and then we often have one overlayer with our application configuration, because sometimes environment variables are a little bit a pain in the ass. And it's nice if you just have an application YAML file, you have one Docker base image, all you do is copy this config file into this Docker image and you have your internal Docker image. I'm not sure what's wrong here. Okay, we are in this microservice world, so we initially, like I showed the UI already, but what we do here is no magic for this latency stuff. In our opinion, the Spring metrics provided weren't good enough, so we built some libraries for Spring, and others did so for Go and Python. But basically we just agreed on a common format. So this is how Z1 expects metrics if you want to use the UI. Obviously, I showed you twice now that checks alerts is pure Python, so it doesn't expect anything. But if you want to have some of the nicer UI features, we had to agree on something. So basically, once services provide data like this with a status code first, and then the HTTP method, and then basically the path, we could start building a common UI for everyone. And this is basically what drives our cloud UI here to show the different applications perform stuff. So basically this is the screenshot when you open the demo now and some people start using the demo. This is basically what you will see. You will see a lot of requests coming in for the Kairos DB endpoint and for the check results for the dashboard. And this is basically relying on the data format earlier. If you're more curious about certain endpoints, what's important here is that there are more charts and data tracked, so you can select any one of your API endpoints, and you get basically your common 200 response code charted. You get to see the deviations, so whenever something is wrong, you see this on the time axis, and we plot the latency for you, so median and maximum latency, which is also a good metric to have. We did this for Spring. We have a nice Python library around Swagger called Connexion, driven by the Swagger first API first definition. It uses Flask. We have it for Clojure. Try it out, Freebo. It's really what we use in the Stups environment to build our services. It helps a lot here. And then, yeah, if you're curious, I think we're also running out of time. It almost fits. There is a demo available. There is documentation on the internet. And we would be really happy to find someone to deploy and test this and help you out if you are interested in this. We have been using it for 2 years and it's still serving us well. Yeah, thank you for listening.
Thank you so much. Do you have any questions to Jan? We have a few minutes to go.
Did you have any issue with Kairos DB stability? Because we've been trying it, it crashed sometimes.
Yeah, this is. I think we have an issue with it because we still haven't migrated completely to AWS with enough resources. there are some issues there. We are actually, or I'm having a pull request for KairosDB switching from Netflix Hector to the DataStax CQL driver. So one of the problems was just the old driver. So this is in the works for us, and it's also on the Zalando repository. So this improved, let's say, speed and availability for us, because sometimes nodes were not responsive for Hector. We are sometimes facing some KairosDB issues, yes, but I still think it's, in terms of metrics and time series data, on some chart it was maybe not visible due to the resolution, but we are pushing 500,000 data points in there every few minutes, so it's a lot of stuff and it works. Yeah. And it's also great to have this infrastructure, so it's very easy once you have it to push via or from any other application time series data into KairosDB with this HTTP endpoints. So I would only advise people to look into KairosDB for time series data. That is very helpful to have, even with the basic UI they provide.
Okay, thank you. Any more questions?
Yes.
Oh, okay. We have two questions over here.
Are you totally dependent on Simon, or are you using any other external provider like PagerDuty, New Relic, anything, or you're, you know?
So far, we have been relying almost solely on Zedmon for 2 years, but we recently decided that we may need something like this application performance monitoring, so more JVM insights data and more request tracing across all the microservices. So there we went with a different provider. But Zedmon is still something that gives you much more power to also have higher level KPIs, like from data warehouse and so on. But we have one contract with another monitoring tool to really look into the JVM. But then what is nice here in this heterogeneous environment, at least in our opinion, is that with this HTTP pull of data, we can suddenly talk to the Go stuff, to the Node.js stuff once they expose the metrics. And this is kind of what you want, because we are not limiting anyone more to Java only. So we quickly saw an adoption on all the other languages and runtimes.
Okay, what I understand that Zedmon is an application used to measure your backend applications. Can you tell in a few words, how do you measure performance of your front-end applications?
This depends so heavily on the team. I'm not sure, you mean latency in terms of page rendering, or?
Exactly, yes.
I'm not sure how they do it. We tried, let's say, New Relic and AppDynamics for this end-user tracking, so some JavaScript injection, but this is not done in Zedmon. So we do track the render time in the backend, for example, for the fashion store. We track all the stuff that is happening in the backend, but we are not doing any real client-side or customer-facing measurements there.
Okay, thank you. And one question.
Do you have any anomaly detection system for your metrics?
What we are using is, we have some functions implemented in Python that so far look in the week-on-week data. So if you can configure some deviation from last week's behavior, but we are not right now in the place that we have some automated anomaly detection. So most of the stuff is relying on week-on-week comparison if they use it. But this is actually something we want to look in the future, obviously, yes. We are storing really gigabytes or terabytes it is of this metric data, and obviously you need to do something with it, yes.
Thank you so much.